So here are the topics of today's lecture. So as we have done in actual loading chapters, I will first begin from the definition of pure bending. Because as I told you, we'll do like a divide and conquer strategy first. So we'll just study only non-zero and or other reactions zero case, which is actual loading first. Then we considered t equal non-zero and other reaction becomes zero case, which is torsional loading. And today and in bending lectures, we'll consider non-zero M case and other reaction becomes zero case. So after going through these reactions one by one, then we're gonna combine them like a near midterm time or after midterm time. Okay, so we'll begin the definition of pure bending. Only M is non-zero or other reaction becomes zero case. After defining what is pure bending, we'll discuss about how we can obtain bending deformation of a symmetric member. And as a third topic, we'll try to obtain the stress and strain distribution caused by the pure bending. Okay, so please have in mind that we'll focus on like a pure bending case where only M is non-zero. Okay, so let's begin from the first topic. So let's discuss about the definition and example of pure bending. So one of the example I want to bring up is the weightlifter. Okay, so when you watching Olympic games like a summer Olympic games, you sometimes see weightlifting games. Okay, so here there is like a man or a woman, and you're gonna have like a huge mass here, which give rise to like a large gravitational force mg. And given this kind of free body diagram, and for simplicity, let's say that we can ignore the mass of this bar. Okay, in that case, out of three sections, you can see that there can be three sections: this section, and that section, and that section. Out of these three sections, we can think about which one would be pure bending status. Okay, so this is the question we can ask, and we can answer the question. So if we draw the free body diagram of the bar, these F must be the mg of these large weights on left and right side, and this F is the force that this human should exert to make a force balance of entire ABCD beam. Okay, now let's try to make a imaginary cut here between A and B. Okay, so when you make an imaginary cut here, the only external force is F. Okay, and to make a force balance, you need shear force V, vertical force, which is heading upward direction. Now if you have like a V and F only, you can see that combining V and F, this material want to rotate in counterclockwise direction. So to balance this torque, using the torque about the centroid point, you need moment M, so that this counterclockwise torque due to F and V and the clockwise torque due to M cancel out each other. So you can see that at AB section, B is non-zero, M is non-zero, so that you cannot say that this is pure bending case. However, when you consider BC case, when you try to make an imaginary cut here between D and C, let's see like what kind of reaction you need to make a mechanical balance. So in terms of force, you can see that the F due to mass, F due to like hands, they already make a balance. So you don't need any vertical force at imaginary surface. The only thing you have to worry is, due to this pair of F's, you need some sort of, counterclockwise torque to balance it out, to cancel it out. You need opposite direction moment in clockwise rotation torque. Okay, so you can say that within BC zone, it can be considered as pure bending. What about CD? So if you make a imaginary cut between C and D, this is the imaginary cut. You have three forces here, but as I told you, we already went through, there is like a 1F downward, 2F upward. To make a force balance, you need non-zero V, so that you can say that CD is not pure bending. So out of these three sections, only BC is under pure bending, and the focus of this chapter will be only pure bending cases. Okay, so let's think about another example. Suppose that you have a cantilever beam adhered to rigid wall. So when you have this external loading P force, point of force putting the beam downward, and if you try to make an imaginary cut, yeah, this point force and shear force V, they should make a force balance. Then you need the vertical force V, so that you can say that this is not pure bending problem. Okay, so this is a case, the typical case of bending problem where you have both V and M, and we're gonna discuss about non-zero V and non-zero M case in shear moment diagram discussions, which gonna follow after this class. After this chapter. Then as a third example, let's think about eccentric loading case. Okay, so when you try to clamp something on the like a little plate or desk, okay, so what you can expect is when you try to I would say install a clamp, there's gonna be force acting on two sides of this grips, clamp grips. Okay, now if you make a imaginary cut here, and you can think about what kind of reactions you need to make a force balance. Okay, so this is the imaginary cut that I make in the figure on the left, and you have force, upward external force, and to make a force balance with this upward force, you need a downward force. And here, because your imaginary cut is horizontal cut, you need N to make a force balance. Okay, and if you, even though you have N and P here, you see that force equilibrium is satisfied and the torque equilibrium is not satisfied, and this torque is acting in to make a counterclockwise rotation for this object. So to cancel out those the torque, you need clockwise moment to balance it out. So you have non-zero M, you have non-zero N, so that you can say that this is not pure bending problem. Okay, so as you can see in many examples and many small video lectures, the basis of doing ME231 is you need to know how to draw free body diagram. Only after drawing free body diagram you can do statics analysis. Only after statics analysis you can correctly decompose problem into several small problems and correctly define what kind of loading it is. Okay, so as I told you, please do a lot of practice on drawing correct free body diagram, and that will be the first priority of you if you haven't taken the general physics course in how to say with good grade. Okay, so if you didn't put enough time during general physics course, please put your efforts on make up the statics and free body diagram analysis in ME231. Okay, so with that, let me finish second video of today's lecture here, and we're gonna move on to bending deformation analysis in the next video.